we move ahead to the next module of stationary waves. In this very module, we are going to learn the numericals which are based on the concept of beats. And this is the second part of it. Means we'll be continuing with the numericals on the beats. So, moving ahead, in this module, we face this kind of a problem. In this problem, it says that there is a wire which is having unison with the tuning fork having a frequency of 250 Hz. When stretched by a weight which is hanging vertically. Now the weight is hanging vertically, students, and the frequency is 250 Hz. Now what do I do with this weight? I immerse the weight in the water. Now, after immersing the weight in the water, definitely the net weight or the apparent weight will change, and due to that, there will be certain change in the frequency. As we know, frequency depends on tension. That is why the wire produces 10 beats per second with the same fork. Now, what do I need to find out? Calculate the density of the material of the weight. Now, how to go ahead about this problem? Let us write down whatever the given data is. We know that the wire is being hanging vertically. We also know that it is in unison with the fork of frequency 250 Hz. So, I'll write down that frequency as N1, which is equal to 250 Hz. Now, after stretching, you know that when I immerse the weight in the water, the next frequency produces 10 beats per second. So can I say N2 must be N1 minus 10, and that will come out to be 250 minus 10, that is 240 Hz. So I have two frequencies. First, when the weight is hanging vertically without immersing in water, and second case, the weight is immersed in water, so there will be a new frequency which produces 10 beats per second, and that frequency is given as 240 Hz. We move ahead. We know that the density of the water is 1 gram per cc. So what do I need to find out? We need to find out the density of the material. To find out the density of the material, we have a general formula with us. The formula states N1 by N2, which is equal to square root of rho divided by rho minus 1. Now with the help of this formula, we'll be solving the problem. Now students, to solve this problem or to go ahead about the solution, I know that N1 by N2, which is equal to under root of rho divided by rho minus 1. Yes, indeed, I have the value of N1, I have the value of N2. Can I now substitute those values over here? On substituting those values, I get 250 divided by 240, which is equal to square root of rho divided by rho minus 1. Now students, 0 and 0 will get cancelled, so the equation will become 25 by 24, which is equal to square root of rho divided by rho minus 1. Now from this equation, students, you can very simply analyze that in this equation, all the other quantities are known. Only one quantity is unknown, that is rho. So I have one quantity that is unknown and one equation. How do I solve it? I solve it very simply, that is by squaring on both the side. When I square on both the side, I get on the left hand side 25 square, that is 625, and 24 square, that is 576. So it is 625 divided by 576, which is equal to rho divided by rho minus 1. On further solving this, I get 625 multiplied by rho minus 1 and 576 multiplied by rho. On further opening the brackets, I get 625 rho minus 576 rho, which is equal to 625. Now on solving this, I get 49 rho, which is equal to 625, and on solving that, I get rho, which is equal to 625 divided by 49, which comes out to be approximately 12.76 gram per centimeter cube. Now students, remember, with the help of this module, we studied the concept of beats problem, but along with that, we had the relation of density. Now this kind of problem, students, star mark it as very important because this can be asked in examination for approximately 4 marks. So with the help of this module, we generalized the category of the concept of beats problems and also mixture of density problems in them. So students, thank you. Meet you in the next module.